Hi, on this slide I will discuss about IPv6 Acls. The Acls functionality in IPv6 is similar to Acls in IPv4. All IPv6 Acls must be configured with the name. IPv6 Acls allow filtering based on source and destination addresses that are traveling inbound and outbound to a specific interface. IPv6 ACL support traffic filtering based on IPv6 option headers and optional upper layer protocol type information for finer granularity of control, similar to extended ACLs in IPv4. To configure IPv6 ACL, firstly, we configure ACEs with two commands. The first command is Ipv6 access list and enter the name of the access list. And then we enter the command deny or permit protocol, source, address, port, destination address, and then the destination port. To apply an IPv6 ACL to an interface, we use a command on the interface mode IPv6 traffic filter following the inbound or outbound direction. Now we open the package tracer file configuring IPv6 ACL. This is the topology. Part 1. Configure, apply, and verify an IPv6 ACL. Logs indicate that a computer on the PC2 network is repeatedly refreshing a web page that is causing a denial of service or DOS attack against server 3. Until the client can be identified and cleaned, we must block HTTP and HTTPS access to that network with an access list. Step 1. Configure an ACL that will block HTTP and HTTPS access. Because we identify the PC2 network that caused the DOS attack, so we should create an access list on router 1. We create an ACL named block HTTP IPv6 access list block Firstly, we deny the HTTP from any source to the IP address of the server. I get the IP address of the server. Equal World Wide Web. And then we block HTTPS traffic. We change to the port number 443. It's the port number of HTTPS protocol. And now we allow all other IPv6 traffic to pass. Permit. So after create the access list, now we apply the this access list to the correct interface. We should apply this access list closest to the source of the traffic to be blocked. So it will be the gigabit Ethernet 0/1. And the direction is inbound. So after configuring, we should show our access list by using the command do show run. We apply the ACL, and here's the rules of our ACL. Step 3, verify the ACL implementation. On PC1, we open the web browser and we use HTTP to browse for the website on the server. You can see that we can access the website on the server, and now we use the HTTPS. You can see that we also can access using HTTPS. Now on PC2, we open the web browser and access the website on the server 3. It returns request timeout. We cannot access. And now we use HTTPS. We also cannot access. But I try to use ping. You can see that I can ping to the server and get the reply. Part 2. Configure, apply, and verify a second Ipv6 ACL. The logs now indicate that your server is receiving pings from many different Ipv6 addresses in a distributed denial of service or DDoS attack. Now, we must filter Icmp ping request to our server. Step 1. Create an access list to block Icmp. We will create an ACL named block Icmp on router 3 and deny Icmp from any source to any destination. But we allow all other Ipv6 traffic to pass. From any source to any destination. Step 2, we should apply the ACL to the correct interface. So in this case, Icmp traffic can come from any source. So to ensure that Icmp traffic is blocked, regardless of its source or any changes that occur to the network topology. Apply the ACL closest to the destination. So it means the gigabit Ethernet 0/0 on router 3. With the outbound direction. And we can show our ACL by using the command do show Ipv6 Acls. And we can show by using the command do show run. On gigabit Ethernet 0/0, we have applied this ACL. Step 3. Verify that the proper access list functions. I ping from PC2 to the server. As you can see, it returned destination host unreachable. On PC1, I ping to the server. The same result, destination host unreachable. So the ACL works. Now, from the PC1, I open the web browser and using the HTTP protocol, you can see we can browse for the website on the server, or I can browse by using HTTPS. You can see we still get the result. Thanks for watching.